Hi guys, and welcome back to the Freelander EV project. And what we have here is a little 3D printed adapter plate which I designed on a child's 3D package called Tinkercad. The reason I used the child's 3D package is because I haven't a clue how to use AutoCAD. I did install a couple of AutoCAD type packages on my computer, couldn't figure out how to use them, so went back to what I do know, which is the child's package. But it worked. I was able to get everything accurately made. And what the plan for this is to put it onto this. This is a prop shaft coupler from a BMW, and that basically goes on like that and gets bolted in the same way that one is. You can just about see that. Okay. The idea then is that this goes on to the coupler, or it goes on to the center of the friction disc. That gets welded on there, then gets bolted on there, and the whole thing gets bolted together. Now what I've done is I've got this one has a center which is the correct size for the Freelander friction disc, and this one is the correct size for the Fate friction disc, and this is the one that fits onto the motor that I'm using. So in the video that you're about to watch, I talk about this a lot, the triangle, and that's what I'm talking about when I mention a triangle. I should say, by the way, that this is not to scale as far as thickness is concerned. All I was interested in was making sure that I could get the spacing between the bolt holes correct and the size of the center circle correct. Now obviously, because this is 3D printed, perfection of sizes, you're usually 1/2 mil out or something like that, so it's not perfect, but at least I can see that the alignment is correct and that the holes are in the correct places and so on. So this is not the final product. I won't be able to decide how thick to make these until I have the gearbox off and I know exactly how big a gap I'm going to have between the two shafts that I'm trying to couple. So when I've got that far, I will use this as a template to get these triangles cut out to shape. Like I say, I'll probably take them to a company to get them water jet cut out, and something like 1/2 inch or thereabouts is the 10-15 mil will be the thickness of them, but I just did them this size just to see as a proof of concept. So I'm going to show you the butchery that produced these. Enjoy. Now the other thing I wanted to talk about was this. What we've got here is our two friction discs, friction plates, clutch plates, whatever you want to call them. Both of these have similar spline sizes and spacing and so on, and they both fit onto my motor. I'm going to bring him over now and show you the difference. I'll set that there. So this is the original. I'll put the original one on first. This is the original one that I bought for a Fate 124, I believe it is. And as you can see, a little bit of movement, not a massive amount, but enough that that would cause some kind of a rattle, I would have thought. So that was the first one I bought. This one is, I'll give you the part number in a minute, but it's from a company called Blueprint. So I had to look at the box there. Blueprint. And I would say slightly more movement on that. But I'm aware that I'm not going to get a perfect fit. And even if I was to take the motor and give it to a company and ask them to make a coupler for this, which would be a perfect fit, I would suspect they would not make it perfectly. There's no way anybody could try and manufacture these splines to perfection. So what I plan to do is the best I can. And what I plan to do is to put one of these on and tilt it to the left, and put the other one on, something like that, and tilt it to the right. And between the two of them, one tilted to the left, one tilted to the right, there is no movement at all, totally solid. Now, is that going to be strong enough for a 500 horsepower car? No. Will it be strong enough for my 80 kilowatt Nissan Leaf motor? Probably. If it's not, I'll be reporting back in 6 or 8 months or a year's time telling you it didn't work. But for now, it's going to enable me to get going and get my coupler made and get the thing in the car, because even if it does fail in some stage in the future, that would not be a major job to replace and repair. So I'll bring these back over now. I'll show you the part numbers for these discs. Right. Let me see if we get these the right way around. That one went with there, and that one came from there. So the Blueprint is an ADC 43101. Available for around £22 from Amazon. I'm sure you can buy them from other sources, but that's where I got that one from. And the Fate clutch plate is a DE7F. I presume that's an I, not a 1. Made by AISIN. Now this one cost me significantly more than £23. I think it's more like £43. I think it's a slightly tighter fit, but I'm not entirely convinced in the quality of the steel. To me, that looks like sintered metal steel, which has been put into an oven and heated up to a very high temperature and sort of melted together. Whereas this one looks more like it's been machined, or I don't know how they make clutch disc centers, but that looks more like a machined piece of solid steel, whereas this one looks more like it was made with sintered metal. I'm not sure if that would be as strong. I don't know. I'm no expert in steel and the strength of it and the longevity of it, but it would be my opinion, for what that's worth, that looks like a higher quality part than that one. So just my opinion, this one seems to fit slightly better, but I'm not sure the quality of the steel. This one I think has better steel, but doesn't fit quite so well. So you pays your money and takes your choice. So these two friction discs, friction plates, whatever you want to call them, from a Fate and another car, are about to meet Mr. Disc Cutter. There you go. That's what I was after. Now I've just checked, and it looks like the diameter of that part, the inner part, is the same as the diameter of this part, inner part. And that's kind of important because if these are going to be on the same piece of triangular steel, they need to be the same size. Here's hoping I don't just cut up a 40-pound friction disc for nothing. Same again. Okay, well I have the two of them cut apart now, and they're close but not exactly the same size. This is one of the rings. As you can see, there's a little bit of movement there. On this one, no movement. But I'm not too worried, because what I'll probably do is put this one on into the triangle, get it welded first, make sure the triangle is cut with a hole the correct size for this. That can be welded in first, and then put onto the shaft of the motor, put this on, put it in, and while it's actually on the shaft, get it welded up. But this will be the one that will be actually supporting the position of the whole thing, so it shouldn't be an issue. I guess if this isn't perfectly aligned, there might be a slight imbalance, purely because of the weight of this being slightly off, but I'm not going to worry too much, as long as this is the one that is a good fit. Perfection this isn't going to be, but we'll do our best. We'll do the best we can, and if it turns out to be not so good, we're not throwing a fortune at it, and it can always be redone at a later time. So anyway, we'll work with what we've got. It's the best we can do. Bye for now.